Okay, students, let's talk about section 2.1. So in section 2.1, we're looking specifically at frequency distributions. A distribution. Guys, that's just a nice fancy way of saying a way to look at how something is being described, okay, in a certain structure, particular data set, or even a population. It's just kind of that distribution. How is it laid out? A frequency distribution is a display of the values that occur in a data set and how often each value or range or values occur. Now, that frequency we talk about, we like to actually use F to kind of shorthand it. So if you ever see like a little F, that's referring to frequency. And those are basically our numbers of how many times that data value shows up in that category. Okay. Now, that category we're talking about is actually given a name, and that name is called a class. Okay. And a class is just basically a group of that data that we're talking about. Now, when you are looking at frequency distributions and the data, some of it is an ordered array, and that's basically it's an ordered list of data from largest to smallest or smallest to largest. If stuff is already in an ordered array, it makes life a little bit nicer, but not always needed. Then we have a probability distribution. And a probability distribution is a theoretical distribution that's used to predict the probabilities of a particular data set that occurs in a population. Normally with these, you are going to see either decimals or percentages with your probability distribution. And then we've got our ungrouped frequency distribution. Okay, so with an ungrouped frequency distribution, it's where each category kind of represents a single value. It's not like a group or a range of values. It's just kind of like, this is how many people said 1, this is how many people said 2, this is how many people said 3. Okay, so it's not normally a group or a range. So a grouped frequency is where they are arranged in groups. So when you're making a frequency distribution, and I'm going to go through these steps a little quick here, the first thing you need to know is how many classes or groups should you have in that distribution. Typically between 5 and 20. If you've got more than 20, you probably have too much data and you may want to look at a different method. 5 is about the ideal area of what we're looking for. Okay. Step 2 is once you know how many groups you're going to have, you need to have an appropriate class width, and we'll look at how we find that number itself. And when you're doing these grouping and how the class width is, it is really helpful to kind of have a class width that is a whole number. But if you need to, you can have one that's got a decimal in it, but just make sure that it's a sensible choice. These are kind of, I'm going to show you a step of how to do it, but sometimes you just want to maybe throw that out the window and make like more reasonable areas of what that class width should be. Okay, once you've figured out the class width, then you're going to start with your class limits. You need a lower limit and an upper limit. Okay, and as you've got your lower and upper limit, then again, you're going to fill that out for every single different group you have. And the last part of your frequency distribution is determine the actual frequency of each class. So how many times does something show up? Now, I used some words already in there. So again, class width is basically the difference between the lower or upper limits of 2 consecutive classes. And then I also use the words lower class limit and upper class limit. These are basically when you're looking at a grouped frequency distribution, this is the lowest number in the class and the highest number in that class, the way you're grouping them together. So let's take a peek at this lovely frequency table here. Okay, now this is just literally the data itself, and we're going to make this into a frequency distribution. So the first thing I begin to notice as I am making this into a frequency distribution, I'm reading in my problem that one, they want it as a frequency distribution, but they said 5 classes. Okay, so this is basically what we would call the raw data, and we need to make it look really nice and pretty. Okay, so let's start with, we want 5 classes, so I need to kind of make note of this is small and this is large. This is an ordered array, meaning it is in that beautiful from small to large order. So I'm making note of what's the smallest and what's the largest because I'm going to need that in a second. Okay, so because we were told how many classes to have, we're going to start by figuring out what that class width is. So that's like step 2 in the problem. And to go with that, the first thing I need to know is I need to know that low and high. So I'm going to take that low and high and subtract them and divide by how many classes I have. So I'm taking that 1999 minus 1595 and dividing it by 5. Again, this right here was given to us in this problem in particular. Sometimes you are having to figure that out on your own. And again, this is the highest in the data minus the lowest in the data. I swear I put an EST, I promise. Okay, now when I did that, that makes it about 80.8, which I'm just going to round up to an 81. And as I'm looking at that, this would basically give us what we call the class width of that 81. However, we're talking about TV prices here. I'm actually going to say most of the time when I go to the store, they talk about TV prices in ranges of 100. So this is what I found mathematically, but I'm going to make a sensible judgment, and I'm going to say, let's go with 100 instead. Okay, and again, I'm just using 100 instead because it sounds a little bit nicer. Plus, it might be a little bit nicer when we put stuff together. Okay, so we're starting with our classes, and again, we're going to want to go with whole dollar amounts. It makes kind of sense here. And remember that 1595 was the lowest number I had. And so what I'm going to do is instead of taking that, normally I would look at it as like 1500, and then the next grouping will start at 1600. So that means this would end up at 1599, and this would end up at 1699. And again, these are 100 apart here. That's why I chose 100. And this seems more reasonable of like how they would advertise TVs. Okay, so we've looked at this and we've broke it now into all these different classes. And again, I have 5 classes as we can see. 1, 2, 3, 4, 5. I see how it's grouped, but now I need to know, okay, how many times does it show back up? So this is where I have to go back to that raw data one more time. So in that raw data, I notice that this is that first group. I also noticed that I do have another grouping, which was that 1600 to 1699. So this would be our class 2. And that would end about here. Okay. And again, all I'm doing is basically counting up how many times does our stuff show up. So with our first grouping there, we saw that it shows up 2 times. So my frequency here would be 2. But my frequency for the next group is going to be 1, 2, 3, 4, 5. And we're just going to continue counting all the way through until you filled out your frequency table. Okay. So I have 2, 5, 4, 5, 4. I've now got my frequency table, and it looks good. There is a kind of a note that you want to do when you're doing frequency tables is make sure that when you take the sum of all of these here, so if I were to add up all of these, make sure that it is actually the same as how many data points you have in the raw data set. Okay. It's also nice to go ahead and just add these all up here. Okay. And double check because it does help you get ready for relative frequencies. Okay, let's talk about class boundaries. Class boundaries is basically a value that lies halfway between an upper limit of one class and a lower limit of the other. Now, finding a class boundary is really helpful for when we are looking at histograms. So the example we were just looking at, let's just keep with those TVs and kind of take it to another level here. So with the first class and the second class, remember with the first class, we had, it was 1500 to 1599. And our second class, which was 1600 to 1699. So I want to take the upper limit of this first class and the lower limit of the next class. So I take an upper and a lower, and I'm basically just going to add them together and divide by 2. And that's going to be the first boundary that we have between the two. Okay. Now that first boundary that we ended up with, which was 1599.5, is going to be the upper boundary for the first and the lower boundary for the second group. Okay. And since we know what the class width was, we can literally just add 100 and get all the different boundaries. So my next one here, this one's going to be 1699.5. This one's going to be 1799.5. And then we get 1899.5. Okay. And then I have to subtract to get this one, which is going to be 1499.5. And the same thing, I'm going to have to get the other side of that boundary there. And so I'm going to get 1699.5. And again, the part that you kind of want to notice as you're doing here is that this and this share the exact same boundary. Okay, it's a boundary, but the upper limit and the lower limits of the next class are not the same. So the boundary is literally what's halfway between them. Now, once you've got that all done together, you've got this beautiful classroom boundary, and that allows us to move into working with histograms a little bit easier. So let's talk about midpoints. So midpoints, these are actually often used for estimating like the average value in a class. They do work out really nicely when you've got a lot of data and you kind of want to just use kind of like what the average is between them. To get the midpoint, you just add the lower and upper limits together and divide by 2. Okay, so again, let's kind of go back to that TV example that we were just doing. And again, I need to basically, for that first class, I'm going to take the upper and the lower limit. Now remind yourself that the upper and lower limits for these was basically what we called that class. So all I have to do now is take 1500 plus 1599, add them together, divide by 2, which is going to give me 1549.5. Okay, so for my first class here, my midpoint is 1549.5. I can repeat the same process with the next one, so I can add these two together and divide by 2, and you should get 1649.5. And if you'll notice that there is a bit of a pattern here, it's again always going to fall back to this class width that we continue to talk about. And again, this was something we chose to kind of round to a nicer number. We originally had 81, and I found 100 a little bit easier to deal with. So this is literally just going to be adding 100 every single time. And with that, we get all of these nice, lovely midpoints put together very nicely, and they're all 100 apart using that class width. So let's talk about relative frequency. So relative frequency is a fraction or percentage. Most often, we're going to look at it as fractions, but occasionally we do have a percentage or a decimal. So the idea, the formula behind it for your relative frequency is the frequency divided by n, where n is this total sample size. Okay, so this F is referring to the class frequency. So basically, I'm going to take the class frequency and divide it by the total frequency. Now, we do have to do this process and repeat it over and over and over again until we get them all. So the first thing I have to do is I need to know what that total frequency is. Now, total frequency is going to be how many items are in the data set completely. So our first thing, that's what we're going to do. And guys, when you see this lovely symbol here, which was on the last slide, that literally means add it all up, sum it up. This is our symbol for summation. So I'm going to take that 2 plus 5 plus 4 plus 5 plus 4. These are all the individual frequencies in the table we created, and we should get 20. So I'm literally going to take each one of these. So here's my frequency table going back to that one that we've already done. And I'm going to take 2 and I'm going to divide it by 20. Okay. Now, ladies and gentlemen, this is where you want to remind yourself that you should be cringing. 2 over 20 should simplify, correct? This is not fully simplified. All fractions should be fully simplified. So this is where simplifying that down should give you 1 over 10. Or, like I said, sometimes it can be written as a decimal or a percentage. All of those are nice, lovely, easy ways in which you can write it. So it should be 2 over 10, but I do have to simplify down, which is 1/10, or it could be 0.1 or 10%. And I'm going to repeat this process each time. So I'm going to take 5 and divide it by 20, which, again, going to need to simplify down to 1/4, which is the same thing as 0.25 or 25%. My next one is I'm going to take 4 and divide by 20, which is going to simplify down to 1/5, or also known as 0.2. 5 over 20 again, which is going to give me that 1/4 or 0.25. And last but not least, that 4 over 20, which simplifies down to 1/5. Again, whatever you do when you're doing these problems, please, please, please make sure that you are always using the simplified fraction. Okay, so if you are struggling with that, please make sure that you go back and we'll review it. But again, all answers should be in simplified fractions. Okay, if you put in 2 over 20, it's not going to go in. Okay, so let's talk about cumulative frequency. Now, this word cumulative, you should have already seen it before. It's pretty much something that shows up in almost every college syllabus. Okay, a lot of times you hear it more in reference to the final. The final exam is cumulative. Well, cumulative just means to add stuff up from previous sections. So as we look at it in terms of cumulative frequency, frequency is how many times something shows up. A cumulative frequency is going to be adding up all the different frequencies. Okay, so let's start with our first group here. So going back to that 3D TV prices, we've got our frequency table, and I'm just going to go with cumulative frequencies. So with my cumulative frequencies, our very first one there, well, there's nothing before it, so it just gets to be 2. Okay, so with the next one, the next group has 5. But remember, now we are summing up. So this is going to be 2 plus 5, which means my new number is 7. And we're going to continue this process all the way down. So make sure that you're constantly adding up the whole way down. Now that you've added all the way down, you should end up with 2, 7, 11, 16, and 20. And again, we should have 20 there because how many data points did we have total? 20. That last number should always end up being exactly how many data points you have. So data is collected on the number of miles that professors drive to work daily, and they're listed below in a table I'm about to show you. Okay. And what we're going to do is we're going to use this data to create a frequency distribution, and we're going to put in our class boundaries, our midpoints, our relative frequencies, and the cumulative frequency for each class. Now, I am going to say we are going to use 6 classes here. Okay. And be sure that your class limits have the same number of decimal places as the largest number of the decimal place in the data. So here is our nice, lovely, beautiful table that they've given me. And they told me that I needed 6 classes. So I went with, okay, first of all, I got to find out what the lowest number is. And this isn't in an ordered array. This is just kind of a free-for-all on the data. So I have to look for the smallest number, which was 1. And I have to go through and look for the largest number, which is 11.9. Subtract those and divide by 6 because they told us it had to be 6 classes, right? Now, when you divide those out, you're going to get this really crazy number of like 1.816, and that 6 is repeating. So normally I'd round that up to 1.8. And I don't know about you guys, but it seems like 2 might be a little bit more sensible. Everybody good with 2? Okay, so let's just switch it to 2. So because our data in miles is more sensible with the use of 2, we're going to start with our lower class limit in the first class being exactly the data point we have, which is 1. Okay, so if our first group is 1, 1 plus 2 is going to give me 3. So my first class is going to have 1, the next one's going to have 3, and then we've got 5 because I'm adding 2 each single time. And these are basically all of my different classes. Okay, so, and if this is 1 and that's 3, 2.9 is the highest I'm going to have in that very first class here. You'll notice I have a decimal point on all of these, and there's a reason for that. So going back to the data, let's take a good clean look at it one more time. Notice that some of my data has decimals and some don't. So this one has 1, 1, 1, 1, 1. That one doesn't have a decimal. So it looks like one decimal place is something I have to consider. So because most of my data had one decimal place, that's the reason why you'll notice almost all of these say 0.0, and that means 2.9 is the highest I can have in there. Okay, so let's start here. I've already gone ahead and done the frequencies for you. So if you needed to go back, pause and go back. So let's get our class boundaries for a second. So again, taking a peek here and here. So 3 plus 2.9, add them together and divide by 2. That's going to give me a 2.95. And that means this is also going to be 2.95. And again, my class width was 2, so this is going to be a 4.95, a 6.95, a 8.95, a 10.95, and so on. And again, I can add 2 all the way down here. That does mean that this class boundary up here is going to be a 0.95, but that's okay. Don't let that mess you up. Okay, so now that we've got all our data there, let's move into our midpoints. So we've got our class boundaries down, our midpoints. Again, all I'm literally doing is a midpoint comes from the class. It's basically the midpoint of the class. So I'm going to take 1.0 and add 2.9 and divide by 2. And when I do that, I get 1.95. I can repeat the process here. So I can take 3 plus 4.9, add them together and divide by 2, which is going to give me 3.95. But I do notice again that these are all going to have that common shared width of 2. So I can just add 2 all the way down. And now that we've added 2 all the way down, we're going to fill out the rest of the table real quick. Okay, I'm going to jump to cumulative frequencies real quick and ignore the relative frequency for a second because this is actually going to help me do the work here. So remember, frequency is referring back to this. Cumulative means I'm taking these and adding up as I go down. So with my first one here, I should have 3 because there's nothing ahead of it. So this and this should always match. But now I'm going to have 6, and I get 6 because it's 3 plus 3. Okay, well 3 plus 3 plus 4, which is 10. And again, we're adding it all the way up until you get to the very bottom there, which is going to be really nice and helpful. Okay, so I got 18. Everybody else get 18 all the way down at the bottom? We had 18 data points, so it makes sense. Well, now that I have that, knowing this cumulative frequency, it actually helps me with the relative frequency because this here is my total, right? So remember with our relative frequencies, I'm going to take a frequency, which was 3, and it's relative to the total, which is 18. Okay, so that very first one is going to be 3 over 18, which should simplify down to 1 over 6. Again, I'm going to repeat that process the whole way down, literally taking each one of these frequency items and dividing it by 18. But do remind yourself that all fractions should be simplified. So let's review really quickly here. So as we're reviewing, the first thing that we want to do is we want to take the number of classes. This is normally given to us in a problem right now, but if you're doing this on your own, you would make that choice yourself. The second thing you're going to do is choose an appropriate class width. A great thing to kind of think about is take that highest value minus the lowest value and divide by how many classes you decided. And then from there, kind of make an appropriate round up to something that's sensible. Once you've done that, you're going to find your class limits. Again, either start with the lowest data point or some smaller number and add that class width all the way until you get enough classes. And then you're going to figure out your frequencies for each. Once you've done that, you can go into your class boundaries. midpoints, relative frequencies, and cumulative frequencies.